I would like to take this video to explain what telescoping series is. Telescoping series is a series of numbers where most terms cancel out, leaving only the first and the last term. So this is a great example to study the telescoping series. So what we are trying to do is we are trying to find the nth partial sum. So we are trying to find the n partial sum. Another way to say this is, let's just open this up. Say, what is this equals to? When n is equals to 1, I have 1 over 3, and then minus 1 over 4, right? And then we plus. Why plus? Because we are doing a summation. That's why we do a plus. And then when n is equals to 2, I have 1 over 4 minus 1 over 5. And then when n is equals to 3, I have 1 over 5 minus 1 over 6. And then we have to keep on adding. When n is equals to 4, I have 1 over 6 minus 1 over 4 plus 3 is 7. And then now you catch the pattern, right? And then n is equals to 5. You have 1 over 7 minus 1 over 8. And then you keep on adding. And then you will reach to the nth term, right? So which is n equals to infinity. And then you will have 1 over infinity plus 2, and then minus 1 over infinity plus 3. And then let's take a look. Let me switch to red. Okay, now, do you see that you have, okay, this one may be the first one. It is better to use a highlight. You have a minus 1 over 4, and then you add the 1 over 4. Do you see that? You add the 1 over 4, and then you have a minus 1/5, and then you plus the 1/5, and then you have a minus 1/6, and then you add the 1 over 6. And then let me switch back to a pen, and then you have a minus 1 over 7 and a plus 1 over 7. We didn't write a super long line, so that means the minus 1 over 8 will get rid of the next term. So whatever before that will get rid of this. So that means what do we have left after we extend the entire line? So what do we have left? So after they all cancel out, because a telescoping series, a series of numbers where most terms cancel out, leaving the first and the last term. So the very first term we have a 1/3. The very last term we are adding minus 1 over infinity plus 3, which is a 1/3 minus a 0. So that is equals to 1/3. So that is the sum. When you are adding that many terms, and then that is the sum. So since the sum is equals to a real number, so we say the series converges. So that is a great example of studying the telescoping series. Another way to do this is, I didn't do that because that is not related to a telescoping series, is you can break this down into two series, n equals to 1 and then infinity, 1 over n plus 2, and then you subtract another series, n from 1 to infinity, 1 over n plus 3. You can use the nth term test. So that one I discussed that in the previous video. The nth term test. The nth term test says you do the limit as n approaches to infinity, 1 over n plus 2, and then you do the limit as n approaches to infinity, 1 over n plus 3. You can say this is equals to 1 over infinity, that is equals to 0. This is 1 over infinity, that is equals to 0. So what that means is the nth term test is you write out every single sum. You write out so A1 plus A2 plus A3, and then you keep on adding until you reach to the A infinity. So you are looking at all the way to the right. So when n is very large, and then you have a 0, so that means this is a sum of many 0. So the sum of many 0 that is not going to make the sum go straight to a positive infinity. So therefore, we say the series converges. So since that is equals to 0, that is equals to 0, we say the first series converges, the second series converges. When you subtract them, the sum is not going to become infinity. So therefore, the entire series converges using the nth term test. So nth term test nth term test for convergence and or divergence. Okay, but this one, what we did above, is using a telescoping series. All right, so that is the end of this video. If you like the way I explain telescoping series or some math like that, subscribe, like, and I will meet you all in the next video.